Welcome back to this video series on nPM PowerUP. In this video, we will look at how to use the advanced fuel gauging capabilities of the nPM 1300 PMIC. If you want to just test it out, you can use one of the default battery models that are found inside the nPM PowerUP application. What you do is you go here and you select your battery manufacturer and the model that most closely resemble the capacity of your battery. Then you select a slot on your kit and write the battery model to this. And you see that the estimation of battery state of charge and time to empty changes based on which model is selected. If you don't find a model that closely resembles your battery, you have to generate your own battery model. And to do that, you need the nPM 1300 fuel gauge board in addition. So here I have prepared my kit with the nPM fuel gauge board and connected it to the nPM 1300 evaluation kit. The way to profile a battery is to go into nPM PowerUP. With this connected, select Profile Battery, and you name your battery. I'm naming my Leopold 1350, which is the battery I have. This is a 3.7 volt nominal battery, which means it terminates normally at 4.2 volts. I want it to stop discharging at 3 volts. This battery is 1350 milliamp hours. And because this battery is so big, I can charge it at the full rate. The built-in thermistor of this battery is 10 kilo ohm. You can also select others, and you can ignore NTC if you're using a 2-wire battery. Then you profile this battery at room temperature. You also want to profile it at a low temperature. I'm selecting 5. And then you also want to profile at a high temperature. I will select 45. So you have 20 C increments. Then you select the folder where you want your battery model to be stored. I'm storing mine in a folder I've named My Models. And then you have to connect power to the PMIC so you can fully charge the battery. You want to do this in a temperature chamber, not on your desk like I'm doing now, but this is just for demonstration purposes. Then we click continue. And what happens here is that the battery will start the PMIC will start charging your battery full. Once it's fully charged, it will start discharging. And when it's at 3 volts, it will start recharging again, but in between you will get a message to change the temperature of your temperature chamber. So this process, the discharging and recharging your battery again 3 times, can be lengthy because you have a max discharge rate of 1 C, depending on the size of your battery. Which means that it can take up to 48 hours to perform each cycle of charge and discharge. So you're looking at 3 times 48 hours for a full profiling. And we can't sit through this in this webinar. But once this profiling is completed, you will have a fully generated battery model in the folder you selected. Let me just abort this. And the battery profile will end up here in Profiles. In the next video, we will show you how to implement fuel gauging using this custom battery model in a Zephyr RTOS firmware application, building on the work we did in the previous video of this series.